As I look through the room, I see a lot of people that I can tell work on hard problems. Very complicated. Obviously, you're always looking to get the most speed out of what you're doing. Time is of the essence. And what I want to talk about is something somewhat different, which is a more pragmatic problem that we see in HPC today. Have any of you guys ever had this conversation? Yeah, I'll make you look at the charts now. Where you have new users coming out of left field that want to use your cluster. And so you try and help them out. You ask them some questions. In some cases, they don't know what a scheduler is, let alone how to use it. I've heard this conversation more times than I believe from administrators everywhere. Everybody from data scientists to the art department coming to clusters. It's crazy. So we've got a challenge here, and when I've talked to administrators, usually when I mention we got a product that tries to make things easier through a graphical interface, they say, oh no, we use command line. And then I ask them, well, what about those new guys like that are coming trying to take advantage of your cluster for something like AI, or they're coming off a workstation and want to use the cluster? And they say, oh yeah, we have workshops, 2-3 day workshops, and they don't get anything I say, and then I've got to handhold them through all these things. So that's really a pragmatic problem. Has nothing to do with, floating point or anything like that, but it's one of the things we're trying to solve here at Lenovo is how do we expand that value? And so the more I talk to admins these days, the more I find that there are new users coming. That's a good thing. We want to grow our HPC value in environments. And particularly with AI, but some other applications as well, they're really looking for speed beyond a single box, whether it's the laptop, whether it's a workstation, whether it's AI with a workstation and a GPU in it. They're really looking to go faster, just like the rest of us. And so in most organizations, there are HPC clusters, whether they're academia, whether they're enterprise, manufacturing, other places, and they look out at this shiny supercomputer that they hear so much about and they want to use it. The challenge is it looks really good till they try to use it. And so, show of hands, anybody not using a command line scheduler? Yeah, that's what I thought. I'm not a person who can use a command line scheduler, just so you know. This is Windows, just so you know, full disclosure. So these tools are really foreign. And for these new users, and again, we want to grow the value of what we do here. The learning curve can be steep, but even more so from the admin time, the training curve can be very steep as well. So what we've created is a solution we call LiCO, and really it's designed to accommodate these new users, whether they're HPC users, whether they're AI users, whether they have some other type of workload that would benefit from a cluster. So we leverage a GUI abstraction of open source cluster management tools that have been around a long time. We'll talk about what those are. We don't put any limitations on those tools so that the typical user that knows how to use them, knows how to write scripts and do Slurm commands and all that stuff, can go on about their business. But for these new users, providing a lot of user-friendly features for them to be able to deploy and manage jobs of the cluster without a lot of hand-holding. In particular, a lot of these users are coming wanting to use clusters for AI. So we've built in a lot of functionality specific to those users to make it very easy for them to deploy jobs. Data scientists can bring code and not have to learn how to use a cluster, how to set up nodes, how to bring packages. For those non-data science folks, like I mentioned, the art department, I've heard that one more than once where they've got a large set of images for something, or maybe it's a medical group that's got a ton of images that they want to take advantage of, don't want to go out and hire a data scientist to build models for them. We've also created our own models that don't require coding. You just bring the data set and you can run it on the cluster. For those folks in AI that really trying to stay bleeding edge, TensorFlow tends to come out with a new release every month or so. We let the user manage their container versions, and we do that through Singularity, and I'll talk about a little bit more why that's so nice both for us and for them. And then we extend that to do things like provide TensorBoard within the console itself, so the user can stay in one spot, do their deployment, do their job management, do their monitoring of these training jobs as well, without ever having to get outside of the interface. So what LiCO is, it stands for Lenovo Intelligent Computing Orchestration. This is Lenovo developed software out of our HPC and AI team, and it brings together a number of open source tools into a single GUI for those users to make the use and management of our HPC type resources much easier for them to use for both HPC and AI workloads. I did mention it is an open source space, so we're actually taking advantage of the OpenHPC project for most of the tools. Again, adding some Lenovo value add components and then extending these with capabilities to manage and use things like OpenAI frameworks, providing workflows for the users, job management. So again, that orchestration becomes very easy for them. So here's the basic stack here. A lot of these will look familiar: Slurm, Ganglia, Singularity. The CUDA libraries, particularly for AI, where most of these folks are trying to train on GPUs. And then we extend that with the AI frameworks, again, through Singularity containers. And then where LiCO sits is on the top, and we've got a user portal, but also an administrator and operator portal where we can not only use the cluster, but monitor that as well, manage those users, things like that. So what we're basically doing is abstracting that stack, which most of you probably know and love, for the people that have no idea what it is. And so this delivers simplicity, not only for our AI users, but some of these new HPC users as well. I don't know if anybody in this crowd has gotten the mandate to provide a GUI. I've seen a lot of things. There's, it seems to be a checkbox exercise. I've seen some simplistic open source GUIs out there just to meet that checkbox. But really, we want to make sure our users can be effective and not just building scripts within a web interface. So again, for new users, here's how we simplify it. We provide predefined templates, both for some HPC workloads as well as AI workloads around the specific frameworks. You can also create your own custom templates for pretty much anything you want to run on the cluster. You can make them as easy or as granular as you want for the user. And then the user simply has got to select one of those templates, fill in a few fields of what they want, again, depending on what's required there. And then they're able to deploy that job, monitor the logs coming out. If it's AI, get to things like TensorBoard and whatnot. Again, for the AI user, we are building additional functionality in here because they have slightly different demands than we typically see in HPC. But the concept's very similar. Make it as easy as we can for them to not have to understand what's underneath making things work. Let them get to work. So, I don't really want the high-priced data scientist spending his time doing software configuration or learning how to use a cluster. I want him doing his data science and deploying his jobs, getting his results, working on his hyperparameter tuning and things like that. So I mentioned those non-data scientists. This is where we provide, for a lot of popular use cases, pre-built models that are around things like image classification, object detection, instance segmentation, medical instance segmentation, as well as some things around natural processing. And what these do is give them the ability to bring a data set. So where an institution has a large data set that could be very valuable in terms of applications for AI, but they don't have the expertise to build those models. We've built models for them so they can simply bring those and deploy those to the cluster. We also let them manage their shared storage space. So if it's something like NFS or GPFS in the back, they can do that with drag and drop access both in and out. They can do things like edit files within here, text files, or preview images that have been output from an AI model in terms of inference to validate models that way, and let them access the logs and everything right from within the GUI. And for the rest of you guys, there's what we call expert mode. So full console access through the GUI, or you can use it direct like you do today. But this gives you the ability to, if you want to have some kind of hybrid implementation where you may want to use drag and drop storage for some unknown reason, or job management through the portal, you can do stuff either through the console, through LiCO directly, and take advantage of some of these other features as well. I did mention, I talked mostly about the user side, but we also do provide an administrator and operator side. So this provides things like cluster monitoring. So we can look at a number of different views of the cluster infrastructure, either by list or through graphical views of your racks. You can customize this to your data center to get the views you want and be able to drill down into systems and see things like CPU load and power, memory, storage access. And for the AI clusters, this is something we see more in the enterprise where they're primarily a cluster around GPU systems. We've got a view that actually looks at just the GPUs across the whole cluster. So when they're doing this training, they want to look at what's the utilization on these? Is my code being efficient? Is it not working? And it's a handy view to be able to troubleshoot some things pretty quickly. We also do things like alerts, reports in terms of billing, queue management for Slurm we can do through here, through the interface. So if we've got an administrator that's not particularly versed on some of these tools, they can do a lot of capabilities here as well. When we were looking at expanding this GUI from HPC to AI, we needed a way really to make the deployment of the AI framework simple. Instead of having people having to define these and things, we needed a mechanism to be able to pull these out of the communities and make it really easy for the users to deploy these as part of a job template. And Singularity was the perfect fit for that. And so what we did was we built in functionality into LiCO to actually manage those containers and create them in order for them to be able to be chosen in the corresponding templates. So there's two pieces to this. One is we let the user create and manage those containers within LiCO so they can pull that container in. If it's a TensorFlow, the latest version, for example, the user can pull that down and create that container, and then that is exposed in the template as a choice. So when they go to run these jobs, they can do things like, if I'm just poking around on a CPU, I can use this CPU version just by switching which container I use. If I'm getting the latest version of TensorFlow and something doesn't work and I want to try it on the previous one to see is it me or is it them, I can do that. If I want to pull in other types of containers and compare them like NGC, I can do all that within LiCO. And then the other thing we've done is that we started out initially just using Singularity for AI containers, but very quickly it became apparent this was pretty helpful in HPC for those new users as well, to where you can containerize whatever you want in Singularity, and we can build a custom template to take advantage of those. All right, so Singularity is really helpful to me as a product manager. The best part about it for me is it just works. It helps with the AI problem that we were trying to solve. So we provide some pre-built containers, but really users can have the flexibility to go bleeding edge if they want or try different things. They don't have to set these things up. They don't have to worry about setting up software stacks on their nodes or their workstations. They can just choose the container they want to use and go within the template. Again, we let the users manage these. Some like to be very bleeding edge. Some like to do different types of tests, compare CPU to GPU on these things. But we don't want them to have to call the administrator to go figure it out. So we try and make it really easy for the user to be self-sufficient here. If we look at the breadth of things out there, Docker, NVIDIA, I think, is here with their GPU cloud containers. being able to spin up something like Jupyter Notebooks or R Studios on the cluster. We actually have some customers that want to do stuff like that. None of these are a problem for us because of Singularity. So it's really helped us make this ease of use story possible. And what I've seen here so far, particularly with what Sylabs is doing, I know probably none of you will use the GUI, but I imagine a day where in the very near future, I can have a user use the remote builder, build a container, drag it into LiCO, and never touch the command line. And I know that sounds silly. Pulling a container in the command line is very easy, but that's the first request I always get is, hey, can you do something in the GUI so I don't have to ever, my users don't ever have to touch the command line? So there is another set of people in the world that actually like that. So just FYI. Okay, so just to kind of wrap things up here and hopefully keep us on time. This new advent of AI and the power of our HPC clusters and the natural fit from the workload perspective gives us a big opportunity to grow HPC environments and the value out of those with AI. There's a lot of things being happening right now around AI research and experimentation, trying to drive value out of that both in research and enterprise. And this gives us a great way to bring in those users easily without the headache of dealing with them. Okay, so our clusters become very simple even for the most experienced users, and I'm testimony to that. The specific functionality that we've put out for AI, again, addresses the specific use case that seems to be coming in predominantly right now. But we're trying to keep the interface open so that pretty much anything that could run on a cluster and benefit from that, that we can make it very easy to set up for users to go with things like customized templates, making them very simple or very granular if there's things to do that. And again, we do have the admin portal as well, so we can consolidate all those tools as well on that side for simple views of what's happening in the cluster. And I just want to point out, I'm supposed to have some obnoxious banners in the back to let you know I'm Lenovo and sponsoring, but I actually have, it's on my laptop now, but LiCO that I can show live demos. So during the breaks or during the reception, if you want to see more or have more questions, want to poke around, feel free to join me at the back table and we can do that. All right, so LiCO is a part of Lenovo's HPC and AI solutions. We're not just a software company, I know, shocking, Lenovo, but we've got a broad portfolio of systems, networking, storage that are Lenovo. We do a lot of systems specific to HPC as well as AI in terms of dense compute, direct water cooled, dense GPU systems. Within our HPC and AI solutions, we also bring in a number of partners. And what we do in our HPC and AI solutions is we validate all of these components, all the firmware are interoperable and find the right versions ahead of time that make these things perform. With that combined with things we can do in the factory in terms of doing integration at the rack level, being able to run things like LinPack to validate not only performance runs, but find fallout in the factory instead of when they show up on your floor. We can provide a solution that gives us mass customization, but with solution support. And as part of that, things like XCAT and Confluent open source management that we support as part of this as well. And LiCO, this is what we call our Lenovo Scalable Infrastructure Solutions. LiCO is also the 2018 Editor's Choice for Best AI Product or Technology. And we're very proud of that. We're more proud of the awards won in collaboration with clients. So folks like Cynet up in Canada, LRZ in Germany, University of Birmingham. We're even more passionate about what we do with clients. And a big shout out to the Singularity team for their 3 awards as well. Woo! There you go. All right. So really, we talk about complex problems and pragmatic problems. But at Lenovo, what we're focused on is how do we help folks like you in different institutions solve the hard problems, what we like to tag as humanity's greatest challenges. And so we look at where Lenovo is working with clients, not just around infrastructure, but in many cases, collaborations. There's a lot of institutions around the world doing a lot of things with Lenovo hardware and Lenovo support that really contributes to improving the world. We are the #1 provider of supercomputers on the top 500 list. We achieved that position in June last year, extended that lead towards the end of the year at SC18. Very proud of that as well. This is the vendor commercial part, just in case you were wondering. Oh, and by the way, we also make laptops. And so, does everybody have your tickets from when you signed in? Okay, make sure you have your tickets, and make sure you're at the networking reception, because we'll be giving away a ThinkPad X1 as the grand prize. Any questions? Okay, like I said, I've got a little setup back here. If anybody wants to stop by during a break or the reception, be happy to talk more about this.
We have a question over here.
You have a question?
Oh, I'm going to go here first.
I just have a quick question. So the LiCO is designed for the system or the user, because as you've created a Singularity container, you need a sudo permission. I wonder how that works for a general user.
That's why I want the remote builder. So you can build it locally and deploy it, right? That's one step. What we're looking at is, do we put functionality in here to build that? And that's a bit of a challenge, is getting to the root user when we don't want the users mucking around in there. So that puts either some burden on the admin to help with those, or else if they can build them on their local machines and then upload them into LiCO, they can do that. I think with Remote Builder, there's an opportunity to solve that challenge when we get there here very soon.
Hey, JJ, how current do you guys stay with OpenHPC?
Oh, great question. We stay current with OpenHPC. And the challenge is some things move faster, like Singularity, right? So it's one of the struggles we've been working through because we like the benefits we get out of that OpenHPC. But it does create some challenges, so we're working through, how to do that. Now, the good news is Singularity 3.1, I believe, is part of the next OpenHPC. So in June, I'll be caught up. It's just a recurring question of what do we do in the meantime when there's innovation in the community that we're looking at some different options on.
I think that's excellent. Can I just take a quick straw poll? How many people care about OpenHPC in the audience here? Quite a few. Okay, great.
Excellent.
Thank you.
All right.
Okay, let's thank our speaker.